Good afternoon, everyone. On behalf of Department of Computer Science and Engineering, Sri Chandrasekharendra Saraswati Vishwa Mahavidyalaya, we warmly welcome you all to this expert lecture on applying Indian knowledge systems in artificial intelligence. We are honored to host this intellectual enriching session today, where tradition meets technology through the wisdom of Indian knowledge systems. Let us make this event more insightful by a prayer song. Now I request Sushma from second year to render the prayer song.
श्रीगणनाथ सिन्दूरवर्ण करुणसागर करिवदन लम्बोदर लकुमिकर अम्बासुत अमर विनुत सिद्धचारण गणसेवित सिद्धिविनायक ते नमो नमो लम्बोदर लकुमिकर अम्बासुत अमर विनुत सकल विद्या आदिपूजित सर्वोत्तम ते नमो नमो लम्बोदर लकुमिकर अम्बासुत अमर विनुत. We extend a heartfelt welcome to our distinguished guest, Sri Nikhilesh Gushe, co-founder and CTO of Acquire Lang, who is joining us to share his deep insights into this fascinating topic. We also take this moment to welcome our dignitaries, Dr. M. Senthil Kumaran, Head of the Department of Computer Science, and COE Dr. Konda Srinivasa Rao, sir, all the faculty, and all of you for this event. We thank you for your presence and support.
To formally begin this event, now I invite Dr. M. Senthil Kumaran sir, Head of the Department of CSE, to deliver the welcome address.
So it's good afternoon, one and all. So it's my honor and privilege to welcome you all on today's invited talk on applying Indian knowledge system in artificial intelligence. So on behalf of Sri Chandrasekharendra Saraswati Vishwa Mahavidyalaya, so I extend our heartful, warm welcome to the distinguished person and speaker of this program, Sri Nikhilesh Gushe, actually co-founder and CTO of Acquired Lang Systems. Actually, sir is from Mumbai. So I welcome you, sir. So I also extend. I'm happy to welcome our respected controller of examination, Professor Konda Srinivasa, sir. So I welcome you, sir. So I take this opportunity to welcome the heads of various departments like Sanskrit, so Mr. Professor Naveen, sir, and Dr. Ramesh, sir, from HOD of MCA department, and fellow faculty members and my dear students. So it's a great talk. It's applying Indian knowledge systems in artificial intelligence, especially the computer science and engineering as well as computer science application students and few Sanskrit department students are also available. Okay, so by merging all these things, we'll get a lot of exposure with respect to the Indian knowledge systems. Once again, I welcome you all on this occasion. Thank you.
Thank you so much, sir, for the warm welcome and for setting the tone for today's session. Now, we would like to invite Dr. Konda Srinivasa Rao, sir, Controller of Examination, to honor the chief guest. Now, let's get to know more about our chief guest.
It is our pleasure to introduce today's speaker, Shri Nikhilesh Gushe. He is the co-founder and the CTO of Acquired Lang, a stealth mod research startup based in Pune. Working at the intersection of artificial intelligence, Naya Darshan and Sanskrit Vyakarana. Over 20 years of experience in entrepreneurship, consulting and software development, Shri Nikhilesh has made remarkable contributions to the healthcare, media and telecom sectors. He previously served as the CTO at Swasth India, headed products at 24K, and co-founded a media startup, a location-based service company before smartphones became the mainstream. An IIT Bombay alumni, Shri Nikhilesh Gushe completed his BTech in 2003 and continues to inspire innovations at the influence of technology and ancient wisdom.
We truly honored to have him with us today. Now we kindly invite Sri Nikhilesh Gushe to deliver this expert session on applying Indian knowledge systems in artificial intelligence. Sir, the stage is yours.
Hello. The first thing I would like to ask is how many students are computer science related? Can you raise your hands? And how many come from the Sanskrit background? Okay, good. So thankfully I've prepared this for computer science students. And sorry, there'll be slight font mismatch because there might be words like these because we have to run it on a different computer, but let's see. So I'm going to start with the story of artificial intelligence in general. And I think though in college you would have to some degree learnt about it, but it's not given a historic perspective that what happened. So and before that, you would roughly see there's a curve, and there are these sort of two dips which are there, which are called AI winters. So we'll slightly go into this. So in 1950s, somebody called Alan Turing. How many have heard the name of Turing? Few, obviously. So Alan Turing is the one who described Turing machines and who created a Turing test, which basically means that if you can write a program and a person talks to it and he is not, a human being cannot distinguish whether a human being is replying or a machine is replying, then it is supposed to, the program supposed to have passed the Turing test. And that is sort of gave us the benchmark of what is intelligence. Then there was somebody called McCarthy, who is considered the father of artificial intelligence. All this is happening in 50s and 60s. The computers are not there. They are large machines in large rooms running fuel, which actually, and these guys are still thinking of how to make them intelligent. But what happened, so basically what happened was that this does not scale because the hardware was not ready. This does not succeed. But in this phase, something happened. A lot of these ideas which were discussed in this early phase resulted in creation of what we call today programming languages. And so basically, programming paradigms and languages. So is there a course on programming paradigms in your class, in your curriculum? You can say yes or no. No. Okay. How many of you know functional programming? No. Object orientation. You can raise your hands. Object-oriented programming? Okay, few. So, what are the languages you're exposed to, if I can ask, Professor? Oops also, but they're not somehow raising it. Okay. So, it is in 1960s and 70s when primarily languages got created. These languages C was created, which is a procedural language. There are 4 kinds of basically paradigms which got invented in that time. And I'll now actually come out of it and a little bit think. This is a quote by Dijkstra, who sort of is considered the father of structured programming, who says a language should not, actually it's a little cut from it, a programming language should not just be concerned with what a machine can do, but also as much with what a man can think. So this part, what a man can think, is what we are going to get a little bit deep into, and this is what connects Indian knowledge systems with the computer. After this point, I am again going to sort of quickly skip it because I think what happened after this point is what a man can think was tried to, as the hardware got better, people started to think, how can we make machines think and talk like humans? And the first thing that came up was something called expert systems. This is a Japanese sort of an invention, which are also called rule-based systems. So you must have seen in films that Japan has these lot of vending machines which have complex logic, that you put a money in it and you tell it that buy me this and it will give you a particular combination of things. All that is a result of expert systems. Expert systems, and this is an era which lasted till 2012 when somebody called Geoffrey Hinton invented deep learning. How many of you heard the word deep learning? Almost everybody. You know Geoffrey Hinton? No. So I insist that anybody who is serious in computer science should go and read Geoffrey Hinton's work on deep learning, who invented deep learning. That happened in 2012. So whatever happened after that, the last thing is LLMs. Everybody knows ChatGPT, right? So this 2012 onwards is separate from what happened before it. And we can roughly say that the first is a deterministic AI. The word deterministic means that when you know exactly what to expect from it. Whereas the second is probabilistic, we don't exactly know what to expect from it. So you must have seen that ChatGPT does not always behave nicely, right? It might sometimes give wrong answers because it's probabilistic. So roughly, you can divide the era of the evolution of AI in 3 phases. The first was a very preliminary phase. Then there was a great phase of determinism, where people tried to make hard-coded systems which were rule-based, which would tell a long if-then-else chain to tell it exactly what to do. And it did not succeed much. But the principles was the manipulation of symbols can achieve intelligence. Basically, it sort of thought that I can write a program which is symbols, and manipulating them can somehow make the machine intelligence. It assumed that representing knowledge is at the center, that whatever we know about the world, the leaves are green, the sun rises in the morning, such statements, when told to it, will create intelligence. Formal logic with neat approaches of programmed by hand. People wrote programs where they wrote these if-then-elses. People thought this will succeed, and it did not somehow succeed. What succeeded was that recognizing patterns in large data sets can achieve intelligence. That you don't exactly tell it what the truth is. You let it find patterns in the data. Machine learning is at the center, not representation, not telling what it to do, but it itself learning. So vector-based algorithms which are learned, not programmed or encoded. So how many here have actually done a vector-based AI project? Anybody has? Okay. This is slightly new. Anybody of you use NumPy and Python? Yeah. So that is a vector-based approach, right? So we must have done very preliminary things with it, but entire thing is that you are not using symbols, you're using vectors. You're not, so this is the difference between these two approaches. Okay, I will divide this 2012 to now phase also in 2 parts, pre-generative AI, post-generative AI. So 2017, there was a paper written called Attention is All You Need. This is a paper, one of the authors in an Indian. Before this, there was success in computer vision, OCR, speech-to-text, robotics, but not much of natural language understanding was happening. That started to happen after what we call today LLMs, ChatGPT, etc. Now, substantial success in automated code generation, image and video generation, and natural language generation, all of you use it to maybe also crack exams sometimes. But what it is not able to do, it is not able to explain why it is doing what it is doing. It is hallucinating, it is giving wrong results. It lacks proper reasoning. Try giving ChatGPT a question like all horses are green, some cows are green, all horses cows, things like those, and it will inevitably fail. You give it a proper logical puzzle and it will fail. What it is actually trying to do is just to retrieve from a large data set what should be the answer to your question. It sort of has a lot of information, it does not have proper reasoning. It needs very large data. You can't build your own LLM, right? You can write your own program, or a symbolic program, but you can't write your own LLM. And inability to learn on the go. Even if you point out an answer it has given is wrong, it doesn't correct it. Next time you start a new context, it will not learn on the go. So it is really already starting to matter. These problems are already being noticed. So you will have lots of news items like this. Companies are getting sued in courts. Some chatbot on airline offered a discount which was not available. It lied, basically. Somebody produced the court documentation using ChatGPT, and it quoted non-existing cases, basically. And things like these have been happening now for 3-4 years, 5 years to ChatGPT, and this is being happening. So what do LLMs lacks? Explainability, reasoning, and data efficiency. It requires too much of data. So why can Indian knowledge systems help? So I already mentioned, because they have well thought out and extensively argued answers to what a man can think. Both the deterministic and the symbolic approach did not concentrate on what a man can think. They were still in the realm of what a machine can do, basically. And increasingly in the last 3-4 years in the Western world, a lot of non-technical fields are now collaborating with AI people. You will see that philosophy professors are now giving interviews about AI, because they have to now confront the question what a man can think, basically. And we have sort of 3, there are many fields, but 3 specifically relevant to AI: Nyaya Darshan, Vyakaran, and Vaisheshika, which has extensively, for 2,500 years, we have more than that, discussed what a man can think, basically. And very well argued from all sides. So this is a small skit. World is made up of, somebody says world is made up of stories. The other person says, no, the world is made up of atoms. The first person says, oh, that's just one story, okay. So there are other stories. The problem with the Western world's entire approach is that their world is, material reductionism is what they fundamentally believe in. They think that the brain is made up of atoms and it creates consciousness, and that will determine what a man can think. That's not how our approach to what a human being is. The consciousness is before the physical matter. The consciousness creates the physical matter. So the world is not made up of atoms according to us. And that's why the paradigm matters. So the question is there an Indian paradigm of AI? So we're going to do a very small exploration. In this small talk, I can't do an entire thing. But so I'm going to give a few examples, sample concepts from the 3 fields that are useful in AI. So there are 3 words here: Padartha, Sansarga, and Shabdabodh. I'm going to do this little interactively. People are sleeping. Not the Sanskrit people, from the computer science people. Can anybody tell me what do you mean by Padartha when you hear the word Padartha? Materials. Okay. So we will come to that. So that's roughly what you mean it in common languages like Tamil or Marathi or Hindi. That's what Padartha means. And Marathi Padartha also means a recipe, by the way. I don't know why, but so, but we will get to what is Padartha in the formal sense of Nyaya Vaisheshik. Sansarg, so actually here it is written, meaning of a word. Padartha means Padasya Arthaha, which basically means meaning of a word is Padartha. So why do you say material? Because because of the Western influence, we have started to think that what is real is only material. But there are meanings of words which are, Atma is a word which means consciousness, which is not a material, but it is meaning of a word, and that's why it's a Padartha. Okay. There are non-material things. So time, Kala, is a word. I say Monday. Monday is not a material, but it is meaning of a word, and that's why it's a Padartha in Nyaya. So many concepts that we have as Padartha. Sansarga. We will come to the next 2 when in detail, little bit, feel fast with. So whatever, okay, this is the first sort of, I'll give you Nyaya, I gave 3 words, Nyaya, Vaisheshika, and Vyakaran. I'll give you a very slight historical background, because I think it will be good. So, in our Indian tradition, so we say that Kanadam Paniniyam cha Sarva Shastropakarakah. The way they say in the West that first there was Newton and then there was light, that's how we can say that there was Kanad and Panini, and that is why all Shastras evolved, basically. So Kanad was the one who wrote the Vaisheshik Sutras. And he described this word Padartha, and the entire Shastra is based on whatever can become the object of the mind is meaning of some word, basically. This comes from Kanad Shastra, from Vaisheshika Shastra. And somebody called Prashastapada sort of very succinctly expressed this in Padarthanam Astitva Abhidheyatva Gniyatvani. Existence, nameability, and knowability are three common virtues present in all phenomena. So we say a chair. We have an image of the chair in our mind, and there is a word called chair. There are three separate things: word, knowledge that I have, and the physical thing. This triangle is sort of expressed in this as avidheyatva, gnyatva, and astitva. Astitva is existence, gnyatva is knowability, and abhidheyatva is nameability, it being meaning of some word, basically. So meanings of words serves as units of knowledge, basically. This starts with Kanad. Okay, we will come to the second part of it. Now, though the Vaisheshikas started by saying that the meanings of the words can be categorized in 6 categories, they were later extended to 7 by the Nayayikas. These two fields merged. So I'm going to go with 7. So this is, so think about it. Think about somebody claiming that all words that you know, their meanings can be put under these 7 categories, basically. And first time I refused to believe that this is when I first learned it, and I say, I will try to find one, you can't find one. Give me any word and its meaning will fall in these 7. They are called Dravya, Guna, Karma, Samanya, Vishesha, Samavaya, and Abhava. Now, Dravya roughly means substance. So they have cyclic definitions. Guna means properties and Karma means activities. And they have cyclic definitions. Dravyas are something which can have Guna and Karmas. And Gunas are 24 in number, according to the Nayayikas. Okay, this is same shlok. And many of the concepts that you learn in mathematics and physics and chemistry, all of them are meanings of some words. For example, number. You know in mathematics there is a number line, 0, -1, +1. But that idea is not necessarily understood only in a line form. Nayayikas call it Sankhya, which is expressed as Ekatva, Ditva, Tritva. And they have a different formalism. We say Dvitvam, Ekatvena, Vyaptam. Yeah. So we can say wherever there is two-ness, there is oneness. If somebody told me there are 2 mangoes and asked me, is there one mango? The answer is yes. Because oneness pervades two-ness. Two-ness implies oneness. So this is different kind of way of looking at numbers, not the number line way of looking at numbers. So there are 24 of them. I'm not going to go into all of them. There is Sankhya, Pariman, Prithakatva, Sanyoga, Vibhaga, which are more abstract, which are shared by all Padarthas can have these gunas. All Dravyas can have these gunas. And then there are Rupa, Rasa, Gandha, Sparsha that we can perceive by our sense organs. They are also called properties. There are 24 of them. So this is a sort of a description of the world. The way object-oriented paradigm says that everything is an object and you create a class in Python or Java, their way of thinking about it, there are 7 categories. Only first one of them is object, the Dravya. The Gunas, the Karmas, and the rest of the 4 are paribhashik. They are more definitional. It's slightly more detailed to get into it. I'm not going to get into it. So Nyaya formalizes Padartha as a well-defined object with a well-defined behavior. So this is about behavior, Sansarga. Padartha can be cognitive relation with another Padartha, can have. So we say Neela Kamal, the word, we say the blue lotus, they are related. There is some relation between them. The Nayayikas give a name to that relation. Now, any knowledge we have, we say this room is lit. Okay, so there is light and there is this room. So in our head, the Padartha for room and the Padartha for light gets connected by what they call a Sansarga, basically. And every time this happens. So the 7 types of Padarthas determine which Sansargas they can participate in, basically. So a Guna can participate from one side in a Sansarga, not the other side. So all knowledge a human being can have can be represented as a graph of Padarthas and Sansargas, basically. This is available to us. Now we're going to go to the third part, the Shabda Bodha. This is the final part of the presentation, which is very... whenever the word literally means comprehension. Shabda Bodha, meaning, you understanding the meanings of a sentence. Now, whenever you understand the meaning of a sentence, each word in the sentence will have an individual meaning. I says that, whatever, Amit goes to Mumbai by flight. Now, Amit is a word, Mumbai is a word, flight is a word, going is a word. Now, Shabdabodh means that I connect the meanings of these words by relationships, basically. And there is a full science of it. Meaning of a sentence is made up of meanings of constituent words. And Nyaya has laws of Shabdabodh, which determine which syntactic structure of Sanskrit language generates which kind of sansarga between participating meanings. So given any sentence of Sanskrit language, it can generate a graph connecting the padarthas with the sansargas. I'm going to give an example of it, but first that I will tell you that there is a book called Vyutpattivad written by Gadadhar Bhattacharya in 18th century, which elaborates the rules of doing this for every possible Sanskrit sentence. So for a natural language, we have a compendium of rules which can generate a graph given a sentence. This is an example, simple example, Ramaha Gramam Gacchati, Rama goes to a village. Now the Shabdabodh format for this is Ekatva Vachinna Grama Nishtha Sanyoganukula Vyaparanukula Prayatnavan Ramaha, which basically there is shown in a graph type structure. Ekatva means oneness, Avachinna means limits, Gram means village, Nishtha means containing, containing. Sanyog means contact, and Anukul means causes. So if I read it in English, it means that Ram which makes an effort, prayatna, that causes an action which causes a contact with a village that is limited by oneness. Now, there are rules for converting every possible Sanskrit sentence to this form which are there in Vyutpattivad. Every possible. And there is no other natural language in the world which has this available to us, basically. Only Sanskrit and the Nyaya Shabdabodh gives us the capability of converting meanings of sentences into deterministic graphs, basically. So thus in Nyaya's worldview, the world is made up of meanings of words connected to each other by cognitive relations, not atoms. Okay. Okay. So what does it mean for AI? So these ancient sciences can help us think of new abstractions and formalisms useful in AI and computer science in general, beyond the usual objects, arrays, sets, functions, procedures, propositions, and syllogisms that you today use in computer science. Now, Padartha is an example of such a formalism which is amenable to application of logic, like the symbols of deterministic AI, and have some bit of amorphousness of the probabilistic AI. Now, the deterministic AI failed in the West because it is too rigid. It is mathematical logic. It does not words with the free-flowing meanings of words, which have overlapping meanings and loose structures. Whereas the vector-based algorithms are very fluid, but they make errors. ChatGPT will give an error, like wrong answer, hallucinate. There is possibility of addressing that challenge by creating a deterministic system, which is based on this understanding for creating meanings of sentences. Now, this is what we do. So what we do, I own a startup called Acquired Lang, which conducted a now 8 years, this is a 2-year-old slide, 8-year-long fundamental research on some of these ideas and formalize the new abstractions. So we raised research funds after that. We have now a computer language ready. We'll be launching this year, which is a new kind of computer language, which is a new paradigm, which we call verb centrism. I'm not going to talk about my work today, but this is what we did. And there is a lot of more possibility. We just explored Shabdabodh part of it. There are so many other things in Nyaya and Vaisheshik and computer science, which is useful for computer science. And I'm going to end the presentation here. I have just put 3 appendices here. This presentation is online. You can use it. And so because this is online, I have put a list of appendices, the first list of scholars, granthas, and inspirations. This one I'm going to go through. So Panini wrote Ashtadhyayi, the first and probably the only formal grammar of a natural language, articulated using 6 types of rules, 3 of which are the same as the 3 types of rules in the BNF grammars. How many of you know BNF grammar? Baker Snor form. Automata course hai? You have 1 hand. Okay. So the Baker Snor 2 hands. Baker Snor form is a subset of the Paninian form of defining grammars, basically. The other 3 types of rules can be looked at for inspiration in AI. Akshapada Gautam, who wrote the Nyaya Sutras. I'm going to skip it. This presentation is online. I'm going to give you a QR code. You can download, you can look at it. Kanad, I already mentioned. Patanjali wrote Mahabhashya. I did not mention in this presentation a lot of things that Patanjali has, and one of the very profound lines of Patanjali is Karakanam Pravritti Visheshaha Kriya. What is an activity? How do you define running? it's nothing but how do you define cooking? So I cook in a vessel, I use fire, there is water inside, there is things. So the nouns participate in a particular pattern and it creates meaning of a verb. So Patanjali also he's more known for Yoga Sutras, but he also wrote the Bhashya on Panini's grammar, which has a lot of, which is I think the biggest book which is there in the world, if I'm not wrong. Bhartrhari was a scholar who wrote philosophy of grammar, which basically a book called Vakyapadiya. I am also not going to get details. There's too much to talk about, but I'm just mentioning this. Prasastapada I already quoted, so that you can look at it. Gangesh is the one who combined Vaisheshika and Nyaya schools and created a single system, and Gadadhar Bhattacharya is the one who wrote all that compendium of all rules of Shabdabodh with Prattivad. There is an appendix 2 of contemporary books which are written on the same matter. I'm just leaving it here for you to use and there is an appendix 3 of the things I mentioned. The first paper is a 1959 paper, is considered the first paper of artificial intelligence, John McCarthy, and I recommend every computer science student to read it, the first one. You have not thought about the questions which were dealt at that era. Now we have a very restricted view of what a computer can do in early ages, and it will be more clear to you why Sanskrit is more relevant if you read the first paper. This is the paper from which I quoted that line that a computer language should not just be about what a machine can do, but as much what a man can think. And the third is a list of major programming paradigms. This is not a very academic paper. This is just a URL. You will find definitions. So I think that's it. This is the QR code. You can scan and find this presentation for appendix. Okay.
Thank you, sir, for that eye-opening and insightful session. We all are inspired by your work and the unique perspective you bring into the AI world.
As we withdraw this session to a close, we would like to express our heartfelt gratitude to Sri Niklesh Gushe for taking time out of his busy schedule to be with us today and share such valuable insights.
We also thank Dr. M. Senthil Kumaran sir, our HOD, and for their constant support and guidance. Special thanks to our faculty, coordinators, event organizers, and all the participants for making this session a grand success. We thank you all being part of this event. Have a wonderful day ahead.